Today we will discuss a case of testicular torsion. Testicular torsion occurs when there is twisting of testis around the spermatic cord. So the vascular supply get compromised. So there will be ischemia. Ischemia can lead to coagulative necrosis. Here on this side we can appreciate the normal tubules. And here there is necrotic seminiferous tubules. So there is lot of hemorrhage in between the tubules, and the tubules are more eosinophilic, and the structural outline is preserved. So there is coagulative necrosis of the seminiferous tubules on this side and relatively normal tubules on this side. Now let us focus on normal area. Here we can appreciate some spermatogonia. This round blue nucleus and clear cytoplasm, these are spermatogonia. This spermatogonia can become primary and secondary spermatocytes, and they can eventually become spermatids, early spermatids with a little more big nucleus and scanty cytoplasm compared to late spermatids. So there is spermatogonia with a clear cytoplasm, primary and secondary spermatocytes, early spermatids, then late spermatids. So these are the normal seminiferous tubules. These are the necrotic seminiferous tubules. Here lot of RBCs between the tubules. So there is lot of interstitial hemorrhage. And these tubules, what are the changes of coagulative necrosis? In coagulative necrosis, basic structural outline of the tubule is preserved. Why basic structural outline is preserved in coagulative necrosis? We know that the major cause of coagulative necrosis is ischemia. When there is ischemia, aerobic respiration and ATP production doesn't happen. Instead, anaerobic respiration happens. What is the product of anaerobic respiration or glycolysis? It is pyruvate. Pyruvate converted to lactate. So this lactic acid inhibits the complete enzymatic digestion of the cell. So basic structural outline will be preserved in coagulative necrosis. Then look at these cells. They are more eosinophilic compared to these normal tubules. So more eosinophilic. What is the reason for increased cytoplasmic eosinophilia? One is loss of RNA. RNA is basophilic. So loss of basophilic RNA increased eosinophilia of the cytoplasm. Second is increased binding of denatured protein to eosin. So loss of RNA, which is basophilic, and increased binding of denatured protein to eosin. These are the two reasons for increased eosinophilia in necrosis, necrotic form of cell death. And many are not showing nucleus. Only cell outline is there. No nucleus is there. Only increased eosinophilic cytoplasm, no nucleus. So what happens to nucleus in coagulative necrosis? There is pyknosis, nuclear condensation. Then karyorrhexis, nuclear fragmentation. Finally, karyolysis or dissolution of nucleus. So there is increased eosinophilia due to loss of RNA, which is basophilic, and due to increased binding of denatured protein to eosin. Nucleus, pyknosis, nuclear condensation, karyorrhexis, fragmentation, finally dissolution of the nucleus. That is all about coagulative necrosis. Thank you.